Today's section 3.1 is on quadratic functions and inequalities. So what is a quadratic function? A quadratic function is a polynomial function of the second degree, which means it has the highest power being 2. So when you're talking about a quadratic function, the f of x equals ax squared plus bx plus c is what they consider standard form. Another form that quadratics are often written in is what's called vertex form. And this is the f of x equals a quantity x minus h squared plus k. So it's saying this is arrived at by completing the square, which we did previously when we dealt with circles. So when we're looking at a graph of a quadratic function, there are a few things that we have to look for. We're going to talk about in terms of their transformations. So what is their a value? If their a value is greater than 0. So if it's a positive number, then that parabola or quadratic is opening up. If the a value is less than 0, then the parabola opens down. When you are in vertex form, the h comma k is your vertex. You also have an axis of symmetry, and that will be the equation x equals h, and it has to always be written as an equation. Now, the maximum or minimum, depending on whether it opens up or opens down, is always that y value of your vertex or the k value. We will also need to find our x and our y intercepts. Remember that your x-intercept is obtained by putting a y value of 0, and your y-intercepts are obtained by putting a 0 in for your x values. We will also still be talking about domain and range, and increasing, decreasing, and constant. So those same things that we talked about in chapter 2. So finding intercepts, again, like I said, if you're finding the y-intercept, you're going to let your x value be 0. To find your x-intercepts, we're going to let our y value be 0. Now, these are methods to be able to solve that we've talked about before. You have to be able to either factor, do your quadratic formula, or complete the square. So here's our first example. We want to identify the characteristics of the parabola and then sketch the graph. So the first thing that we're going to look for is our a value. Our a value is that number that's in front of the parenthesis. Well, if there's nothing there, it's a 1. Since it is positive, then I know that my parabola opens upward. Now I want my vertex. My vertex is always going to be opposite of what's in the parenthesis and the number on the outside. So my vertex here would be a -2, -9. Now my axis of symmetry is always got to be an equation, and it's always the x value of your vertex. Now, if your quadratic or your parabola is opening up, then we have a minimum value. And our minimum value here would be y equals -9. Now, your y-intercept, if you want to find the y-intercept, remember our x value is 0. So our y-intercept would be, we play a 0 in, so we'd have y equals 0 plus 2 squared minus 9, which would be 4 minus 9, which is -5. Again, your intercepts always have to be written as coordinates, so this would be 0 and -5. We also need our x-intercepts. Our x-intercepts, remember that our y value is 0. So we would say 0 equals x plus 2 quantity squared minus 9. Add our 9 to the other side, x plus 2 quantity squared, square root. Remember, when you take the square root, you have to put plus or minus. So I would have plus or minus the square root of 9, which is 3. Add or subtract 2 from both sides. So we'd have -2 plus or minus 3 equals x. Now we do have to work out for these two different x values. So our x-intercepts would be -2 plus 3, which is a 1, and -2 minus 3, which is the -5. These x-intercepts also need to be written as coordinates. So they would be 1, 0 and -5, 0. So we're going to go 1 and 0 for our x-intercept, and then -5 and 0. 0 and -5 is our y-intercept. We have a vertex of -2, -9. And then we can draw our quadratic or our parabola. We would have something that looks like that. Sometimes you will see at x equals -2, they will draw a dotted line there because that is your axis of symmetry. Now, what if it's not in the vertex form? Said once the equation is in vertex form, you can analyze the graph of the parabola by using the transformation to the parent function. So we need to write this in vertex form. So to do this, we're going to say f of x equals. Now, we're going to kind of separate some things out. So we're going to separate it like this. When we did this before, we would put a blank on the inside and a blank on the outside. When we did it with circles, we did it on one side of the equation and on the other. Now, we're still going to take our b value. We're going to take our -2, divide it by 2, and square it. That gives me a -1 squared, which is 1. So we're going to add 1. Well, if you add 1 on the inside, because we're on the same side of the equation, we actually have to subtract 1 on the outside. Now, what we have done is made it to where we can put this function in vertex form. We need to factor this inside part. So we need numbers that multiply to 1 and add to a -2. So this is going to give me x minus 1 squared minus 9. Now, as far as transformations, we have no stretch, no compression. It is not a reflection, but our vertex, like we said before, was opposite of what's on the inside and the number on the outside, which is 1 and -9. Now, we can plug in some other numbers. If you plug in 0, we would get -1 squared, which is 1, minus 9 is -8. So 0 and -8. Because we know we have an axis of symmetry at x equals 1, it has to be the reflection on the other side. So at 2, we should also have a point at -8. And that allows us to draw our quadratic again. If you're looking at this, it does have a minimum, and that minimum value would be at -9. So here's a couple more. Now, if your coefficient is not 1, it makes the problem a little more difficult. So the first thing that I would do is I would rewrite this again like we did earlier. So 2x squared plus 8x and then plus 7. Now what I'm going to do is I'm going to factor out a 2. So I'm going to pull a 2 out so that I do have a coefficient of x squared of being a 1. Now when I do this, I would take my 4 divided by 2 and square it. That gives me 2 squared, which is 4. Now, but I'm really not adding 4. I'm adding 2 times 4, which is 8. So if I add 8 on the inside, I must subtract 8 on the outside. So that would give me my vertex form as being 2. Factor the inside, I get x plus 2 quantity squared minus 1. So this time I have a vertex of -2, -1, and I have a stretch of 2. So you can plug in numbers if you want to get some other points. You need at least 3 points to be able to graph the quadratic. You can also use your calculator to help you find some other points by plugging it in. Now, it may ask you what the vertex is. The vertex here would be -2, -1. Our axis of symmetry would be x equals -2. We would have a minimum value of y equals -1. So it just kind of depends on what the question is asking for. On the next one, again, we do not have a coefficient of 1 on our x squared. We have negative x squared plus 6x, negative 8 on the outside. Again, we're going to factor out the negative 1. When we do that, we get x squared minus 6x, and then minus 8. Again, take your b value, divide it by 2 and square it. So negative 3 squared is 9. So I'm going to add 9. But really, I've got negative 1 times 9. So I'm not actually adding 9, I'm subtracting 9. So I have to do the opposite on the outside. So I'm adding it. So my vertex form would be negative 1. Factor what's on the inside. So I'd have x minus 3 squared plus 1. So my vertex would be 3 and 1. Now, it is a reflection, so this one will be opening down, and it does not have a stretch or a compression. So I would have something that would look like this. So in this case, this one would have a maximum value at y equals 1. It has a vertex of 3, 1, an a value of negative 1, which does mean it's opening down. And so that's what you would need if you were graphing those quadratic functions. There is other ways to find your vertex. To find the x value of your vertex, it has the formula that says negative b over 2a. So in this case, our vertex would be negative b, which would make that a positive 4, over 2 times negative 2, which then gives me a negative 1. So my x value of my vertex would be negative 1, which is also my axis of symmetry. To find my y value of my vertex, or my k value, I'm just going to substitute that value in. So I'd say negative 2 times negative 1 squared minus 4 times negative 1 plus 1. So I would have negative 2 plus 4 plus 1, which is going to give me 3. So my vertex would be negative 1, 3. This actually makes it fairly easy to write in vertex form as well, because whatever the a value is on your standard form is also the a value on your vertex form. So I'd have negative 2, and then I would have x minus a negative 1, which makes it a positive 1, squared minus 3. And that would be your vertex form. You can also use your calculator to determine your vertex. So you would graph this, you would go to y equals, and you would graph it. Once you graph it, you would hit second and trace. Since you have a negative a value, you are looking for a maximum. And when you're looking for a maximum, this is the same as when we were doing increasing and decreasing before. Remember, you have to do a left bound, and that is on the left side of the vertex. And then you'll hit enter. Then you have to do a right bound. And on the right bound, you have to be on the right side of the vertex. And then it'll say guess. And you'll just hit enter. And then it will give you the coordinates of that point. You can also do x-intercepts. Instead of doing maximum, you'll see a function that says 0. And you'll still do the left bound and right bound, but when you're doing left bound and right bound, you're doing it of where it crosses the x-axis. From that information, you can determine your increasing, decreasing, and constant. Now, when you are asked to solve quadratic equations, this is what we've done before. So we solve by factoring or quadratic formula or completing the square. So we're going to use this to help us solve quadratic inequalities. So if we solve this quadratic equation, we can factor it. It would be x minus 3 and x plus 2. So if we solve that, we set each piece equal to 0. So we get x equals a negative 2 and x equals 3. So that helps us when we graph. We do know then where it crosses the x-axis. It will cross at negative 2, and it will cross at a positive 3. Now, we still don't know our vertex, but we could find our vertex by doing our negative b over 2a like we did earlier. So it would be 1 over 2 times 1, which is 1/2. Now plug that back in to find your y value. So you would have 1/2 squared minus 1/2 minus 6. 1/2 squared is 1/4. 1/4 minus 1/2 gives you a negative 1/4. So that's going to give me negative 6 and 1/4. So I would go 1/2 and negative 6 and 1/4. And we're going to say we're about right here. We know our quadratic is opening up because we have a positive a value. So we would have something that looks like that. So what we want to do is we want to be able to solve a quadratic inequality. So now we have changed this. We want our quadratic to be less than 0. So what you're doing is you're comparing your quadratic to the x-axis. So I'm going to draw a blue line here for our x-axis. So we're going to say, okay, where is it less than 0? Where is it below the x-axis? So if I'm looking at that, all of this part right here is below the x-axis. So when you do your answers will be intervals, just like when we solved inequalities before. Now, this does not have an equal to sign, so it's going to be a parenthesis. We only are looking at one spot, so we would be saying from -2 to 3 is where that quadratic is less than 0. So you can solve, you can graph, and use that graph to help solve this inequality. So those values I got by solving are what are called critical values. Then you'll sketch it and then write the intervals that solve the inequality. So let's look at another. So the first thing you have to do though is it has to have 0 on one side. So I'd have 2x squared plus 5x minus 12 is greater than 0. So if you're looking at that, you can factor, you can do quadratic formula if you don't think that it'll factor very nice. So let's go ahead and do quadratic formula. It'd be -5 plus or minus the square root 5 squared minus 4ac all over 2a. So that's going to give me inside 25. And then we have what, 48 times 2 plus 96. So 25 plus 96, which is going to give me a -5 plus or minus the square root 121 all over 4. So square root of 121 does work out nicely. It's -5 plus or minus 11 over 4. So if we found our two critical values, we'd have -5 plus 11, which is 6. 6 over 4 reduces to 2/3. -5 minus 11 is -16 divided by 4 is a -4. So those are our two critical values. Those are our two x-intercepts for that problem. So if we looked at this in terms of a graph, we know our quadratic opens up. I know it crosses at -4 and at 2/3, or sorry, 3/2. Now it opens up, so it should look something like this. It's not a great graph. I don't know exactly where the vertex is, but as long as you have the general sketch, you'll be okay. Now, this time we want to know where this quadratic is greater than the x-axis, it's greater than 0. So this time we have two different intervals in which it's greater than the 0. So in this case, again, remember we're using x values. So our solution would be -infinity to our first x-intercept, which is -4. Now it can't include -4 because there's no equal sign, so it's a parenthesis, union 3/2, comma, infinity. Because we have two areas where it is above the x-axis, we should have two intervals joined by a union. So let's go to the next problem. Normally I don't like my x squared to be negative, so I'm going to go ahead and make it positive. So I'm going to divide everything by a negative. Again, when you divide by a negative, it switches your inequality. So now we would be less than or equal to 0. Now, In this case, this is not going to factor. So again, I'm going to do quadratic formula. So it'd be negative b plus or minus the square root b squared. So I'd have negative 3 squared minus 4ac all over 2a. So if I work this out, I have 3 plus or minus. I have 9, and then it should be plus 20, which is the square root of 29 over negative 6. Now, when you look at these will not come out to be very nice numbers, but you can go ahead and graph them as well because it will help you. So if you do 3 plus the square root of 29 over negative 6, so that's going to give you a negative value. So it's going to be 3 plus the square root of 29 over negative 6. Now, if I do minus, it's going to give me a positive value. So it'd be 3 plus the square root of 29. 3 minus, sorry, the square root of 29 over negative 6. So this quadratic, if we're looking at what we just did here, it does have a positive, so we would be opening up. And it's okay that it's not the same as what it was to begin with because we switched our inequality sign. Now, in this case, we want to know where is it less than or equal to 0. So in this case, we're below the x-axis. So we're down here. So we only have one part that we're looking at. It does have an equal to, so I will have square brackets. But my answer would look like negative 3 plus the square root of 29 over negative 6, comma, and it'll be negative 3 minus the square root of 29 over negative 6, again with a bracket. And that's because we have an equal to sign. So let's look at some applications. If a rectangle has a perimeter of 50, what dimensions will maximize the area? So we're going to talk about a rectangle. So I would draw a rectangle. And it says it has a perimeter of 50. So if we think of this as x and this is y, we would have 2x plus 2y would have to equal 50. But we want to maximize the area. We want the biggest area that we can possibly have. To find area of this rectangle would be x times y. So what we need to do is we need to solve for y in our perimeter problem to get everything in terms of the same variable. If I divide by 2, I get 25 minus x for y. So I'm going to substitute that in. I would have x times 25 minus x. So what you're going to want to do here is to graph this on your calculator. And once you have this graphed on your calculator, you are looking for the maximum value. Okay. So again, if we multiply this out, we would have 25x minus x squared, which you can see then is a quadratic that opens downward. So it will have that maximum value. So use your calculator and that feature on the calculator to find the maximum value. Now, if we are trying to maximize the area, we do not want the x value because when you do this on the calculator, you get an x and a y. The x will be this actual length. What we want is the y value because the y value in this case would be our area. If we're looking at this last one here, it says a football is kicked straight up with an initial velocity of 128 feet per second from a height of 5 feet. The height above the earth is the function of time given by this equation. What is the maximum height of the ball? This is going to be the same type of thing. You're going to want to graph this in the graphing calculator. Again, your a value is negative, so you will have something that looks like this. However, you will have to adjust your window. So you will go into window, and you're going to have to change your x-mins and x-maxes to where you can see the whole picture. Another way to do this is to use zoom and zoom fit. Zoom fit will kind of give you to where the picture is, but it may not be perfect. So you still may have to change your window to be able to find that maximum value. Again, when you find this, you will find it x, comma, y. The x will represent the time, and the y will represent your height. This is a good example of a problem that you might see on the final. If you have any questions, please make sure that you send me an email, and I hope to be back tomorrow. Have a good day.